students. Welcome back to our next topic in science class. Today we're going to be talking about something old and something new, something borrowed, but not something blue. And no, we're not talking about a wedding today. We are talking about, believe it or not, fossil fuels. So how do those words tie in to this topic of fossil fuels? Well, sit back and relax and enjoy the show, because today we are going to be talking about fossil fuels. So what exactly are fossil fuels? Well, let's talk about it. In a broad sense, fossil fuels can be described as energy from the remains of plants and animals. That's right. Energy from the remains of plants and animals. Our society, especially today, is entirely dependent upon energy. You're watching me right now because I made this video using a computer, which uses electricity, which is one of the forms of energy. Hopefully, you're watching me in a room that is warm. Why are you warm? Potentially in the middle of wintertime? Because there is something being burned that gives off a heat energy, another form of energy. You can see me right now because there is a light on. Light is another form of energy. Whether you're using a computer or a smartphone or a toaster oven or a TV, or the list goes on and on, you can't escape using energy in one form or another today. Well, the bottom line for us is, well, where do we get that energy from? Well, we are in a major transitional period in our country right now as far as where we get our energy from, but that's another topic for another day. Today we're going to be, and this week, we're going to be focusing on where do we get most of our energy from, and that is through the use of fossil fuels. Most of the energy that we get even today, in fact, about 3/4 of the energy we get today, comes from the remains of plants and animals. Something old. Yes, plants and animals that have been gone, dead, dying, decomposing, squished beyond belief for many, many, many years, even longer than I've been around. And that's going some. So let's talk more about why we use fossil fuels so much. It's something called hydrocarbons. Hydrocarbons are substances that contain, as you might imagine from the name, hydrogen and carbon. These are two elements that exist in the universe, and hydrogen and carbon, when they're put together in a compound, and we'll be learning a lot in 8th grade when we learn about chemistry and how these elements come together and how we can take them apart. But hydrocarbons are substances that contain both hydrogen and carbon. You can see this little model here of a typical hydrocarbon. Let's see, 1, 2, 3, 4, 5, 6, 7. This is actually a hydrocarbon with 8 carbons. It's actually octane. This is a picture of a model of octane, which is something that is part of gasoline that we use in our cars and trucks and perhaps generators. There's something called octane in it, and some gases have a higher level of octane than others, and this is what octane looks like in the form of a model. But getting back to hydrocarbons in general, because there are many different kinds of hydrocarbons, As I said, you can probably guess from the name, but I'd like you to circle and underline certain things in your notes right now. In the word hydrocarbon, circle the word or the prefix hydro. Hydro in this case refers to the element hydrogen. Underline that in your notes. Also circle the second part of hydrocarbon called carbons, and then underline the word carbon in your notes, and you can see why we get the name hydrocarbon. So why are hydrocarbons so excuse me, important in fossil fuels? Well, number one, fossil fuels are made up of a high concentration of hydrocarbons, and that's all fine and good, but how does that lead to us utilizing them? Because we like to burn things. That's right. Burning is more accurately known in science by the word combustion. Combustion is the fancy word for burning. And excuse me for one moment. I have to drink some dihydrogen monoxide, otherwise known as water, to clear my throat a little bit. Much better. So combustion is the burning of hydrocarbons in order to produce heat. And if you see in this particular diagram, here we have a compound with carbon and hydrogen. This is a hydrocarbon, actually known as methane. Methane. And when you burn methane with oxygen atoms, it produces heat energy. And the byproduct, the products of burning methane include CO2. Any idea what CO2 is? Breathing it out right now, carbon dioxide gas, and H2O. H2O. Do you know what that is? There's a hint right there. H2O is water. So when you burn hydrocarbons, or when hydrocarbons undergo combustion, it results in the production of carbon dioxide and water. Now, I mention that because that's the science involved. That's reality. Now, in our world today, there is a huge debate that's been going on for years now about human contribution to the atmosphere with increased levels of carbon dioxide gas from the combustion of hydrocarbons, which we do to get energy from fossil fuels. It's a topic we're going to talk more about it. We'll talk more about the debate regarding the topic in future weeks. But for now, let's just focus on the fossil fuels, hydrocarbons, combustion, and we'll begin today with going over, well, what are the types of fossil fuels that exist in the world? And then we'll begin to unpack them one at a time. So let's begin with the three types of fossil fuels. Number one, this stuff right here. This stuff right here is coal. And we'll discover today that not all coal is the same. The second type of fossil fuel is oil. And by the way, you don't want to be drinking this stuff. That would be really nasty. But oil. We'll be talking more about oil, as well as the third type of fossil fuel called natural gas. Ooh, excuse me. Yes, that type of natural gas and other types as well. So we'll explore natural gas tomorrow, more than likely, because today we're going to spend a bit of time talking more about the first type of fossil fuel, coal. So let's begin here with coal. In general terms, coal is the solid form of fossil fuel. In fact, I'd like you to underline that word solid, because if you paid attention to that list I just gave you, one type of fossil fuel is solid, which is coal. One type is liquid, which is oil. And one type is a gas, natural gas. So we have fossil fuels that exist in the three main phases or states of matter. Again, we've talked about phases of matter long ago, and we'll talk about those a lot more in 8th grade too. So again, back to coal. Coal is the solid form of fossil fuel, and as I said, not all coal is the same. In fact, there are 4 types of coal based on the progression or the stages of development or formation of coal. So we're going to review those 4 stages or phases or types of coal, beginning with the earliest stage. But before we get to those stages of the formation of coal, let's just mention that the formation of coal depends on 3 things. It depends upon heat, pressure, and time. Now I'm curious, how many of you grow gardens? Okay. How many of you have ever heard of a compost pile? Some of you maybe. Now, a compost pile is basically yard scraps. You could put various things in compost piles, but they are generally plant material, whether they are leaves, grass clippings, old lettuce, salad, table scraps that you put into a pile. And some compost piles can grow pretty large. Some of you might have compost piles in some of those fancy units called compost bins, which are like giant garbage containers that you turn around periodically. But if you've ever seen a big compost pile, I'm talking a big compost pile, especially during the winter time, and you dig around in it, and it's a healthy, huge compost pile, you may actually see some steam coming out from it. Yeah, it's actually warm. The decomposition of that organic material is a slow process of combustion or burning. That's right. Not with flames. It's combustion or decomposition without flames, because it takes a long period of time. But the bottom line is the decomposition of organic material produces heat. Now, if you've got this organic material that when it's decomposing is producing heat, and you get a lot more piled on top of it. I grew up in a big family, 7 kids in my family. I have 3 brothers and 3 sisters. And when my brothers and I used to play around, sometimes we play tackle football, and sometimes I wasn't able to run fast enough to get away from my brothers, and they would tackle me. Have any of you ever been tackled by somebody else? Okay. If you've ever been on the bottom of a pile of people, you know that when you're on the bottom of a pile, the pressure is pretty intense. I can remember feeling so squished at times, I thought my eyeballs were going to pop out of my skull. I know, brutal thought there, but woo-wee, because my brothers were bigger than me. Now, imagine that you are decomposing organic material. You're generating some heat, and more organic material gets piled on top of you over and over and over again. You're going to start feeling the pressure of all of that material on top of you. The more stuff that gets put on top of you, the more pressure you're going to feel, and that's going to have an impact on the development of the chemistry going on in your decomposition. Given enough time, Organic material that's generating heat is under a lot of pressure and is there for a long period of time can develop into coal. Now, it takes a long time, much longer than a human lifespan, which is one of the concerns today in our usage of coal and other fossil fuels. It's because they are not renewable. Once we use up those non-renewable resources, there won't be any left. So that's one concern that we'll be discussing later. But let's get back to coal and the different stages of development. The first stage is peat. Now, while you're writing this down, I have a question for you. Peat and repeat were sitting on a fence. Peat fell off. Who was left? Did you hear that? You may have been distracted by writing down the definition. So I'll repeat it for you. Let's see if anyone can answer this riddle. Peat and repeat were sitting on a fence. Peat fell off. Who was left? Did you say repeat? Peat and repeat were sitting on a fence. Peat fell off. Who was left? Did you say repeat again? Peat and repeat are sitting on a fence. Peat fell off. Who was left? Are you getting the idea that this is a joke? All right, hopefully you got it. If you didn't get that, think about it again. You can even replay the video later on your own if you'd like, but I'm not going to repeat it again. But that's a different kind of peat. Let's get back to the first phase in the development of coal called peat, P-E-A-T. Peat is a soft material made of decayed plant fibers. Now, if you've ever played outside in the summertime with bare feet, you've probably felt grass blades between your little toesies. Have any of you ever walked into a pond? We have lots of ponds here in our township. Have any of you ever walked through a pond barefoot? If you have, you've probably noticed that squishy-ishy feeling between your toes. That's decaying organic material. Now, there are many ponds around here left over from the last ice age, and we've talked about that in previous topics. And some of the local ponds are so old that they're filling in from the sides with all of the vegetation that has been growing there over the eons of time. And if you've ever walked along the bank of an old pond, you know there's a lot more vegetation there, assuming that it's a natural pond that hasn't been mowed over and it's not maintained by a landowner. But that drier material is getting closer to what peat is. Given enough time, the ponds around here will no longer be ponds, but rather marshy areas. They'll just be wet areas with some swamp grass growing in them. Given more time, those swamp grasses, the area will dry out even more and it could become a peat bog. Peat bogs, incidentally, are great places around here locally where the bog turtle loves to live. There's a wonderful example of a peat bog not far from here up at Merrill Creek Reservoir. You go hiking along I think it's the Blue Trail, and you can see a peat bog where little bog turtles live. And they're such cute little critters, but leave them alone. All right, they are an endangered species in these parts. But peat also ties into one of our previous topics when we were talking about fossils, if you remember, just down the street from our school, right here in Warren County along Route 46, was a pond that eventually dried up and created a peat deposit, and mastodons fell into it. Mastodons, those ancient creatures like woolly mammoths that lived right here down the street. And mastodons actually fell in and were preserved. You may recall that. They were the best preserved specimens in the country back in the 1800s. And the largest one is still on display at the Harvard Museum of Comparative Anatomy up in Massachusetts. I think we should bring it back, actually. I think we should bring it back to New Jersey and to Warren County. Wouldn't it be cool if we opened up our own Warren County or New Jersey museum and brought back our various fossils that have been located all around the country and the world? Let's bring them on back home to New Jersey. There's so many cool things we could do. I'm getting distracted here, but let's get back to peat. Peat is the soft material made of decayed plant fibers. And you can see in these pictures here, these folks are actually harvesting peat and piling piles here of peat, because peat is a great material to use to amend soil without organic material. It's a great, you can even buy bags of it to amend soil today. And in more ancient cultures and in more primitive cultures around the world that may not have trees, this peat, these blocks of peat that they're excavating from the ground, can be dried out and burned as fuel. They can be burned as a fuel source. Produces a lot of smoke. They don't burn very efficiently at all. But if it's the only thing you have to heat your home, why not burn peat? Not P-E-T-E, P-E-A-T. And don't make me repeat that. All right, moving on to number 2 is lignite. Lignite is also called brown coal. Brown coal. It is soft with a woody texture, and it's formed from continued pressure applied to peat. So if there is a deposit somewhere of peat and it's under other deposits and it's being compressed, squished together, more of the moisture will be removed, more of the impurities will be removed, and it can transform into what's called lignite. There are actually deposits of lignite right here in New Jersey. In fact, I think the video yesterday I made reference to where lignite can be found. Peat can also be found in New Jersey. In fact, right down the street in Great Meadows, lots of deposits of peat. So lignite, also called brown coal, you might want to circle that in your notes while you're at it. Underline lignite, maybe circle brown coal so you can remember. That might be a good quiz question. What is brown coal also called? Lignite, with a woody texture formed from pressure to peat. That brings us to number 3. The third type of coal is called bituminous coal. Bituminous coal is also known as soft coal. In fact, you might want to circle the word soft coal next to bituminous. Soft coal, and there are deposits of soft coal not far from us actually, is dark brown or black, and it is the most abundant type of coal. Most of the coal around is actually bituminous coal. Now, some of you might even still burn coal in your homes as a fuel source. If you do, and you want to save some money, you may use bituminous coal because it is cheaper. But it produces some pretty nasty, foul-smelling smoke, and the ash is disgusting because there are a lot of impurities still found in bituminous coal. That brings us to the fourth and final type of coal, which is called anthracite. Anthracite, also known as hard coal, again in your notes, might want to circle hard coal so when you're studying your notes, you remember which one is which. But anthracite coal is extremely hard and brittle. Now, here's the deal. Anthracite coal is so old that most of the impurities have been removed from it. Anthracite coal is almost pure carbon. Not exactly, but it's almost pure carbon, which means it burns most efficiently. Pound for pound, if you were to burn any of these four stages of coal, you're going to get the best bang from your buck out of anthracite coal because it will produce the most amount of heat with the least amount of coal. And it also produces the least amount of pollution from all of the impurities found in the other types of coal. Now, both bituminous and anthracite coal were influential, very important parts of our industrial revolution past in the United States. In fact, you may have heard of famous canals like the Panama Canal, the Erie Canal, but have you heard of another famous canal that comes right through Warren County, New Jersey? The Morris Canal. I hope you've heard of the Morris Canal because it was pretty famous back in its day for the technological innovations that they made in getting canal boats back and forth, up and down the hills of New Jersey, from the Delaware River all the way over to where the Statue of Liberty is at Liberty State Park. That's where the Morris Canal went. Who knows? Maybe some of you have gone on a canal boat ride over at Hugh Park. Now, that's not the Morris Canal over there in Easton, Pennsylvania. That is I think that's part of the Lehigh Canal. But there used to be a lot of canals around. And why am I talking about canals and canal boats? Well, one of the primary products that they transported from place to place was coal. Bringing coal from fields of coal in Pennsylvania out to the city across the canals in the canal boats. It was a very cheap and efficient way of transporting very large quantities of a heavy material known as coal. So right here in Warren County, you can actually visit one of the Morris Canal parks here in Warren County, and on certain days of the week, you can visit Incline Plane number 9 and see some really cool stuff, believe it or not. But we're going to finish today just reviewing the stages of coal formation. This is a great little picture which illustrates factors, time, pressure, and heat, and goes from peat, and I won't repeat that, to lignite, to the different types of coal, the bituminous and the anthracite coal. So burial pressure, heat, and time is all that's required to change this organic material into peat, lignite, bituminous, and finally anthracite coal. And these are the stages of coal formation. Now, it would be really cool if we could reproduce this process in a laboratory, but it takes way too long for that to happen. But we're going to call it quits here for now because we've gone over a lot of information. We'll save the other types of fossil fuels till tomorrow. Please use your time wisely if you have time after this lesson, and go to Google Classroom and be sure to watch the other videos that I've linked for you. I may be asking questions about them on this week's quiz. But until now, I'll say, or until then, till next time, I'm going to say, bye-bye.